Hello, everyone. I got a question on challenge activity 5.4.3 using regression to make predictions in Excel. So I want to go over how to do that with you. You do need to make sure you have Excel downloaded so that you can download the data in this spreadsheet. And you want to make sure that you have the data analysis tool pack downloaded to your computer and put in Excel as a plugin. And if you don't know how to do that, there is another video on my channel if you scroll down that gives you instructions on doing that. So let's go ahead and take a look at this problem. A researcher is analyzing the relationship between various variables in housing data for 32 cities. And our data is median list prices of single-family homes, condominiums, or co-ops, all homes, median household income, unemployment rate, and population. We want to know the correlation coefficient R for the model that predicts the list price of a single-family home using median household income as an explanatory variable. So basically what we're being asked is there a correlation between household income and the list price of a home? So I'm going to move this over. We're going to pull up the Excel. Okay, so when you open up the Excel spreadsheet, you're going to have sheet 1 with all of our information here. To do the data analysis, you're going to go to Data on the menu, and you're going to come over to the far right on the menu where it says Data Analysis. You're going to have all of your analysis tools, and you're going to want to click on Regression. And okay, now let me delete what our previous data was in here. Okay, so our our Y range that we're going to put in here, and I know that the book has it backwards, so in Excel, the way that this is downloaded, it is mixed up. So the Y range is going to be your explanatory variable, and your response variable is going to go in X on Excel. Okay, so let's see here. We are looking for the relationship between single-family homes, and we're going to use median household income as our explanatory variable. So we're going to put that as our Y range. So if we could scroll to the top here, median household income is going to be right here, column E. So I can't select all of column E because it will take into account this first column here that says household income, and that's just words, so it can't perform a data analysis on that. So I'm going to click and hold in this first cell here and just scroll down till the last data here, and then I'm going to let go. So that's going to give me E2 through E33 for my values. And then for my X range, I'm going to click in there. I'm going to want the list price of single family homes. So I'm going to do the same thing for the single family homes. And that's going to be B2 through B33. And I don't need to click anything else. I'm going to click OK. It's going to give me a new worksheet. Let's see, I'm going to pull this up here. Double click so that I can see everything. I'm really only interested in this value right here. Okay, my multiple R. So that's my R value that's telling me the correlation for these values. So let me pull this problem over and let's put that in. So we have 0.7939, we'll go 9, we'll go there. Okay, so that's our regression value, and then we want to say what is the correlation there. Okay, so that's about 80%, so that's a pretty strong correlation. Moderate's going to be between 40 and 60%, and then weak is going to be underneath 40%. So we're going to click strong, and we're going to check. Oh geez, what is wrong? It is moderate correlation. I'm going to disagree with that, but I guess because that can round up to 0.8, so I can see where they're saying that. So that's going to be one of those ones that's going to be taken with a grain of salt, okay, because technically if we were to round this, that is less than or equal to 0.8. It is equal to it. All right, let's try the next problem. Let's see here. The list price of all homes using population. Okay, so does he think population is going to give us any correlation to a pricing of homes? It doesn't seem so, but let's take a look. Okay, so if we go back to sheet 1, we're going to do the same thing. We're going to go to data, data analysis, regression. Okay, so we are looking for, we said all homes using population as the explanatory variable, so that's going to be our first one. So we're going to go here, population. Okay, G2 through G33. And then it was looking at list price of all homes. That's column D. So let's go over here to my X range. All homes. Okay. Let's pull this out here. We want this first value. That's going to be that 0.114. All right, let me pull the problem over. Okay, so let's put this in here. So we have 0.1147. We can go 77. That'll round up to 8. And that's definitely going to be a weak correlation when we're looking at that. There we go. Okay, and for the rest of the problems, you're doing very similar. Oh, okay, yes, this is different. So now we want to find the equation of this line. So we want the slope and the y-intercept. This is going to be all homes and population, which I believe was the one that we did here. These are the values that you want, but this fun thing with our book is this is not going, now we have to switch it back up. Okay, so we're going to go back to our sheet. Okay, we want all homes. Let me see where we're at here. Move this over, population. Okay, so we have to switch where we're putting this in here. The reason why we were doing it before with the explanatory variable in the in the y range was because it was giving you the opposite value. Like if it was negative, it was giving you positive. If it's positive, it's giving you negative. So just know for this one, when we go to the data, we're going to go the same thing. It's going to go regression. Okay, but now we're going to delete these. Okay, so our y range, this is, let's see, all homes, and then population is explanatory variable. Okay, so we're going to go all homes in the y value. And then in the x value, we're going to go population when we are getting the line model. Okay. This is going to give us what we need here, our x, our y-intercept, and our slope. Okay, so let's go ahead and put that in. Our y-intercept, or sorry, in front of the x is going to be our slope. So that's going to be 0.0466. We'll go 6583. And then this is going to be our y-intercept, 318088.1. What is the interpretation of the slopes? Let's see what we have here. Is this positive or negative? This is negative. So an increase as population increases. And what is the interpretation of the intercept? Okay, so that is going to be the list price of all homes when population is 0. No practical interpretation. So this should be the list price of all homes when the population is 0, or it could really be no practical interpretation because I don't think there's much of a correlation here. Yeah, we're going to go to there's no, yeah, no practical interpretation would be that one there. Oh, I think we're going to actually have to do this again. So unemployment rate and to get to the next problem. So hold on, let me skip ahead and we'll get to the next problem. Okay, next problem is getting the r-squared value. So we just want the coefficient of determination. So what is the coefficient of determination of the list price of all homes using list price of condominiums or co-ops as the explanatory variable? All right, so we're going to run the same analysis. So data analysis, regression. So we have here the list price of all homes. So all homes should be in the Y range. It's already there. Good. And then in the X range, we want condo or co-op as our explanatory variable. Click OK. And we are looking for R squared right here. So let's go ahead and put that in. R squared, 0.921. 767. You don't have to type the whole thing. You could probably do 3 or 4 decimal places and be fine. The interpretation, then you're just converting to a percent. So just move that over 2 places, 92%. Go ahead and check it. Good to go. All right, and that should be good for all of these questions. Thank you. Hope it helps.